So I'm continuing with section 8.3, and I'm just realized that the last two videos there was something wrong with the machine. Hopefully it's fixed now, but I don't have time to re-record. I'm sorry. So now we're talking about the quotient. We were just doing multiplication, and I can rewrite this. I can either have them separately or write them as one radical. And it really just depends. If I already had a perfect square on the bottom, I would just take the square root and I'd be done. But if not, then I'm going to simplify them. Now, once we get to the next section, if we can't just simplify the radical on the bottom, then we're going to have to do an extra step, which is rationalizing. But for this first one, 26 over 2, well, 2 goes into 26 13 times. So that's just the same thing as the square root of 13. Which has no perfect factors, so therefore that's my final answer. The 16y to the 7th over y, well, this y to the 7th over y is going to reduce to y to the 6th, so it's just 16y to the 6th, and that's a perfect square, so my final answer for that piece is 4y cubed. Number 3, that 5's outside the radical, so I have to simplify this first to see if I can do anything with the 5. So I'm just going to write the 5 all the way out front, and then 10t over 90t cubed. Well, 10 over 90 reduces to 1/9, t over t cubed reduces to 1 over t squared, so this is 5 times the square root of 1 over 9t squared, and then I can take the square root of 9t squared, which is 3t, square root of 1 is 1, and then multiply that 5 back in, and I get 5 over 3t. And then number 4, again, that 10 down there is outside the radical, so I'm going to pull it to the side, and then we'll multiply it back in later. So 2y over 8y to the 5th. 2 over 8 reduces to 1/4. Y over y to the 5th is 1 over y to the 4th. So this is 1/10 square root of 1 over 4y to the 4th. And again, that's a perfect square on the bottom. So it's just going to be 1/10 times 1 over 2y squared, or 1 over 20y squared. All right. This next section, you can't just simplify it and the radical goes away. So you're not supposed to leave a radical in your denominator. And in order to get rid of it, we're going to be doing rationalizing. And rationalizing is just multiplying by whatever's on the bottom in the radical to move it to the top. And we multiply the top and the bottom by the same thing because we're making it look different, but we can't change the value. So this is just equal to 1. And we create that perfect square on the bottom so we can take the square root, and then the radical is left on top. So we have 2 over square root of 2. I'm going to multiply the top and the bottom by the square root of 2. So I have 2 square roots of 2 on top, and square root of 4 on the bottom, which is 2. These 2's are both on the outside of the radical, so I can simplify them, and my final answer is just the square root of 2. For number 2, I'm going to multiply by square root of 7 over square root of 7. And I get 5 square roots of 7 on top. Square root of 7 times square root of 7 is square root of 49. I created the perfect square, so we just get a 7 on the bottom. Alright, for number 3, I'm just going to extend this radical over a little bit. Everything's in the radical, so I'm just going to use it. I'm just going to multiply the top and the bottom inside the radical by 11. Or another way to say it is multiply by square root of 11 over square root of 11. So I just did it inside. On the bottom, we get 121. And on the top, we get 22. So I created a perfect square on the bottom. So my final answer is square root of 22 over 11. I'm going to do that again. Just extend the square root and multiply by 5 over 5. And we get 5x squared on top and square root of 25 on the bottom. So square root of 25 is 5. I can take the square root of x squared and I get x. So my final is x times the square root of 5 over 5. Here I'm going to multiply by 50 over 50. So we get square root of 50t over 50. That's 50 squared, and then you take the square root. That can be broken down to 25 times 2. So 25 times 2, square root of 2t over 50. Square root of 25 is 5. I don't know why I made that so big. So 5 square roots of 2t over 50, and then this reduces to 1 over 10. So my final answer is square root of 2t over 10. And then my last one, I'm multiplying by 32 over 32. So I get the square root of 32y over 32. 32 is 16 times 2, so it's the square root of 16, and then the 2y I'm not going to be able to do anything with. So we get 4 square roots of 2y over 32, and again that can be reduced. So my final is square root of 2y over 8.